So, Chapter 9, Learning Targets. I'll go through what's in Section 9.1. So, the first thing in 9.1, letter A, says to evaluate trig functions of acute angles using all 6 trig functions. So, the first thing you have to make sure you know is you need to make sure that you know on the unit circle when you draw any angle in standard position, you have an x value and you have a y value, and then you have a radius. The radius is here. Now, if we're not on the unit circle, that radius could be anything. If it's on the unit circle, the radius is 1. So, once you see that in standard position, then sine, if you think of the SOHCAHTOA stuff, sine is opposite over hypotenuse. So, if here's my angle in standard position, the sine of that angle would be y over r, opposite over hypotenuse. Cosine would be the adjacent leg, which is x over the hypotenuse r. Tangent is opposite over adjacent. So that's where these things are coming from. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Then the other thing we learned is the reciprocal identities. So the cosecant is the reciprocal of the sine. So instead of y over r for sine, we say cosecant is r. Instead of y over r, the cosecant is r over y. For cosine, the cosine was x over r. Secant is the reciprocal of that, so it's r over x. And tangent was y over x, opposite over adjacent, so now cotangent is going to be x over y. So you do need to know these reciprocal trig functions. Okay, so what kind of problems will we ask with that information? So one would be to ask for all the trig values of a certain angle. So in this problem they said angle B, which is right here, this angle. So they want all the trig functions of angle B in exact terms. So before you can do that, you have to find all 3 sides. So when I look at this triangle, I have the 2 legs, so I use Pythagorean theorem. I got x squared is 208. I broke that up into the square root of 4 times the square root of 52, because I knew 4 went into 208. And then I broke 52 up into the square root of 4, because 4 also goes into that, times the square root of 13. So I have the square root of 4, which is 2, square root of 4, which is 2, so 2 times 2 is 4, 4 square root of 13. Now, if you would have known that 16 went into 208, you could have done that right away. But without a calculator, you probably wouldn't have known that. But you could have broken the square root of 208 up into the square root of 16 times the square root of 13. If you had, if you knew that, and then the square root of 16 is 4. All right, but you need to be able to simplify. Now, simplifying is only going to be a small portion of getting the answer. So if you leave it as a square root of 208, you might get a half a point taken off. But we do want you to try to think about simplifying. Probably on the test, it won't be any number that is quite that big. All right, so once you have that, now you have to find the 6 trig functions. So you've got if this is angle B, you've got your opposite leg here, you've got your adjacent leg here, and you've got your hypotenuse right here, which now we know is 4 square root 13. So we're looking at the SOHCAHTOA stuff. So sine of B will be 8 over 4 radical 13. Cosine of B will be the adjacent leg, 12 over the hypotenuse, 4 radical 13. Tangent of B will be the opposite over the adjacent, 8 over 12. Cotangent then is the reciprocal of that, so then you've got your 3 reciprocal ones. Now you do have to simplify, so just so you see what the final answer should look like is, if you're looking at the sine of B and you take 8 over 4 radical 13, you have to rationalize your denominator. So the first thing I did, though, I guess, is I decided 8 divided by 4 is 2. So now I have 2 over the square root of 13 to make it a little bit smaller numbers. Then I multiply by radical 13 over radical 13, so I got 2 radical 13 in the numerator, and I got 13 in the denominator. Cosine of B, same thing. I realized 12 divided by 4 was 3. I had to rationalize my denominator, and that is 13. It's hard to see that. So it's 4 over radical 13, or 3 over radical 13. I multiply by radical 13 over radical 13. I got 3 radical 13 over 13. With tangent, we said it was 8 over 12, opposite over adjacent, but we can reduce that. 4 goes in each of those numbers, so it reduces to 2/3. Then again, cotangent's reciprocal of the tangent. So instead of 2 over 3, it's 3 over 2. All I'm doing is flipping what's in the numerator and denominator. Secant, again, it's the reciprocal of the cosine. So if cosine was 12 over 4 radical 3, I'll flip that, and secant's going to be 4 radical, or 13, I guess it is, 4 radical 13 over 12. And again, 4 goes into there 3 times, but now the 3 is in the denominator. Cosecant's the reciprocal of the sine. So if the sine was 8 over 4 radical 13, the cosecant's going to be 4 radical 13 over 8. And again, 4 goes into 4 once and 8 twice, so I have radical 13 over 2. So you do have to simplify a little bit. That comes from all the things we did in the previous chapter. But the basics of this is making sure you know sine of an angle is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then you need to know the reciprocals. Cotangent is the reciprocal of the tangent. Secant is the reciprocal of the cosine. Cosecant is the reciprocal of the sine. So we could give it to you like that. The other way we could give it to you is we could just give you some information. The sine of an angle is 3/5. So draw a picture. I've got a triangle. Here's angle A. Sine is opposite over hypotenuse. So the opposite leg is 3. The hypotenuse is 5. Use Pythagorean theorem to find out the other missing side is 4. So again, once you have your side, so this is giving you 2 sides, the opposite and the hypotenuse. Now you have to use Pythagorean theorem to find the adjacent. And again, Pythagorean theorem on that would be 3 squared plus what you don't know squared equals 5 squared. So you take 25 minus 9, x squared is 16, so x is 4. Once you have that, you've got your cosine. The cosine of your angle is the adjacent leg over the hypotenuse. The sine of your angle they gave me, tangent is opposite over adjacent. Secant is the reciprocal of the cosine, so it's 5 over 4. Cotangent is the reciprocal of the tangent, so it's 3 over 4. Cosecant is the reciprocal of the sine, so it's 5 over 3. So again, you're just using the SOHCAHTOA and then the reciprocal identities. B says to solve right triangles, including special right triangles. So, and it says to keep them in simplified radical form. That's true only for the special right triangles. So for the special right triangles, you need to make sure you know these formulas. For 45/45, hypotenuse is equal to the square root of 2 times the leg, and the legs are the same, they're equal. And for a 30/60/90, the hypotenuse is equal to 2 times the shorter leg, and the longer leg is equal to the square root of 3 times the shorter leg. Now, the longer leg is opposite the 60, the shorter leg is always opposite the 30. You also need to know the SOHCAHTOA stuff to set up ratios for angles that you don't know, and with those, you will use your calculator. You'll actually use the sine button on your calculator and cosine to find an approximate value when you use SOHCAHTOA. So, on your problems that you have on this sheet, the first one is where you don't know that angle. It's a 38-degree angle. So that means you have to use SOHCAHTOA. So if I'm looking for angle or side B, the side opposite, well, here's 38 degrees. B is opposite. This is the hypotenuse. So I know sine of 38 degrees is B over 7.8, opposite over hypotenuse. How do you solve that? Well, you can find the sine of 38 on your calculator, and then you multiply that by 7.8. To solve this, to undo divided by 7.8, you multiply by 7.8. The one thing you have to make sure you can do is, on the calculator problems, make sure you can go to mode. The mode button is right here. Hit mode, and make sure that your calculator is in degree mode. Just arrow, if it isn't, arrow down, hit enter to make sure you're on degree, and then quit. Second quit. All right, so once you're in that mode, you just type the sine button of 38 and hit enter, and then we want to multiply that by 7.8 to solve for x. That's where I came up with 4.80. To find A, which is this side, if I have the cosine of 38 degrees, that's equal to A over 7.8, and I solved that problem. All right, with the special right triangles, again, this is the hypotenuse, so I plugged it into my equation. The hypotenuse equals the square root of 2 times x. So to undo the multiplying by square root of x, or square root of 2, I divided by the square root of 2, and then I had to rationalize, and then I had to simplify. So that's all the review of what we did last chapter. In this problem, I gave you the hypotenuse again. So our formula says the hypotenuse is equal to is equal to 2 times the shorter leg. So if that's the shorter leg, and I say 14 is equal to 2x, now I just divide by 2, x is 7, and then the longer leg, which is y, is equal to the shorter leg times the square root of 3. So that's where I came up with 7 square root 3. So you need to know those formulas and then be able to use those formulas. If it's a 30-60 or a 45-45, make sure you can plug in which piece you know to solve for the other ones, which means sometimes we have to rationalize denominators. If it's the SOHCAHTOA stuff, that you can use your calculator to solve that. So that's 9.1 A and B.